Hello friends, is time travel possible? In 1955, Flight 914 took off from New York but never reached its destination. Everyone assumed it had crashed. However, 37 years later in 1992, the same plane landed at an airport in Venezuela. The pilot said, "We are 3 hours late." But the ground staff was shocked because, according to their records, this flight was lost in 1955. When the airport staff approached, the pilot started the engines and the plane took off again. It has never been found since. Was he a real time traveler? Is traveling through time actually possible? In today's video, let's understand the concept of time travel from a scientific perspective. In 1895, author H.G. Wells wrote his famous book, The Time Machine. This is when the term time machine became popular, a machine that could take a person both to the future and to the past. Although it was science fiction, it inspired many scientists and philosophers. Serious research papers were written and many movies were made. There could be several methods of time travel, such as Method 1, slow time travel shown in Primer, 2004, a passenger sits in a box, and for every minute spent inside, they travel 1 minute into the past. Method 2, one-way travel to the future. You travel to the future, but cannot return. Interstellar is an example where an astronaut arrives in the future. Method 3, instantaneous time jumping. A person uses a time machine to instantly jump from one time to another. Back to the Future is an example. Method 4, traveling at light speed shown in Superman, 1979. Superman flies faster than light to reverse time. Method 5, time travel can occur when the traveler stands still, and time itself moves around them. This was shown in Harry Potter, Prisoner of Azkaban, when Hermione uses the time turner. The question is, which of these methods is actually possible today? Time travel can be of two types. 1. Traveling to the future. 2. Returning to the past. First, let's talk about traveling to the future. According to Albert Einstein's theory of special relativity, time dilation is possible. Newton believed time was constant. No matter where you go, time passes at the same rate. But Einstein said time is like a river. Its flow can be fast or slow, depending on speed and gravity. Method 1, time dilation through speed. The faster an object moves, the slower time passes for it. Imagine you have two clocks. I keep one clock on the ground with me, and send the other clock with you on an airplane. The airplane circles the Earth and lands. If we compare the clocks again, they started synchronized, but now the airplane clock will be a few nanoseconds behind. This is because it was moving at a higher speed. An experiment was conducted in 1971. Atomic clocks were used. It was observed that the clock on the airplane was behind the other clock. This is called the Haffel-Keating experiment. It proved Einstein's theory of time dilation. If we could build a rocket that travels at the speed of light, and you travel in it for 10 years before returning to Earth, time on Earth would have advanced by 9,000 years. Method 2, time dilation through gravity. According to Einstein, the greater the mass, the more space-time curves, and the slower time passes. Friends, you must have seen the movie Interstellar where Cooper and his team reach a planet closest to a black hole. Cooper says not to waste time there because 1 hour there equals 7 years on Earth. Does this really happen or was it just a movie? Let me explain. A black hole is a place with the strongest gravity in the universe. Einstein, in his theory of general relativity, stated that the stronger the gravity, the slower time passes. This means if we stay near a black hole for a few minutes, months would pass on Earth. A few hours near it, and years would pass on Earth. This is not a joke, it's science. The question is, time slows down near a black hole, but how? If you travel from point A to point B in space at light speed, it will take very little time. If you travel from point A to point B near a black hole, your distance increases. You have to travel more here. But the speed of light remains constant in all conditions. Therefore, when light speed passes through space-time curvature, time must slow down to keep the speed constant. Both these spaceships will arrive at the same time. The people in this ship will have aged 20 years. The people in this ship will have aged 85 years. We just don't know if a human could survive so close to a black hole. On June 28, 2009, Stephen Hawking held a party at Cambridge University. The party had balloons and champagne, but the key point was that the invitations were sent out after the party. Hawking held this party for time travelers. If anyone traveled from the future, they would be welcomed. This humorous experiment shows that traveling to the past is not possible. If it were, we would see time travelers. Now let's talk about, can we go to the past? Currently, we cannot travel to the past, but we can get a glimpse of it. This is because light takes time to travel distances. If we could reach a point before light arrives and then observe the incoming light, the light would be from the past. In this way, we can see the past. You already know this, sunlight takes 8 minutes and 20 seconds to reach Earth. Meaning, the sun you are seeing right now is actually the sun from 8 minutes ago. We never see the present, we always see the past. Similarly, when we see a star at night, that star is not necessarily shining at that moment. Its light left thousands of years ago. The farther the star, the longer its light takes to reach us. This is why, through a telescope, we see the star as it was thousands of years ago. It's possible that star doesn't even exist today, but its old light is still traveling through space. The same applies to the sun. If we had a powerful telescope that could capture light with a delay, we could see the sun as it was 8 minutes ago. So, a telescope shows us the old history of the universe, a kind of time machine. Now think, if we reverse this concept. If we travel millions of light years away and set up a giant telescope, we would see Earth as it was millions of years ago. Because the light from Earth would take millions of years to reach there. If we go 80 light years away, we could watch World War II happening live on Earth. Go 1,000 light years away, and you would see the Egyptian pyramids being built. No time machine needed, just the speed of light and distance takes you directly to the past. This was a glimpse of the past. But can we actually travel to the past? In reality, no. But Einstein's equations do not forbid it. Theoretically, extreme gravity could create wormholes in spacetime, through which returning to the past might be possible. Nobel Prize physicist Kip Thorne has researched this. When we go to the past, many obstacles arise, paradoxes. Like the grandfather paradox, if I go to the past and kill my own grandfather, how will I be born? And if I am never born, how can I go to the past to kill him? This is the paradox. To explain this, there are some theories, like the multiverse theory. According to this theory, when you go to the past and change something, a new universe is created, a new timeline. Meaning, a second universe where whatever you do will not affect your real life. Just as shown in Doctor Strange in the Multiverse of Madness, our Doctor Strange kills his own variant in another universe, and it doesn't affect his life. Overall, traveling to the past has many logical problems. There are paradoxes, which is why it is likely not possible.